All right, the exterior angles are what we're going to focus on now. So the exterior angles of a polygon are an angle that we've talked about exterior angles before. So think about our triangle. We've done this with triangles in the past. So think about our triangle. If I have a line that extends out from that triangle, that looks really bad. There we go. A line that extends out from that triangle. I have an angle on the inside, right here. That's our interior angle. And the angle that's on the outside of the continuation is your exterior angle. So they make up a straight line together. So what does that mean? That they are supplementary, guys. Your exterior angle, can't read that, is supplementary to the interior angle. Now, if I told you that this was an equilateral triangle, all of the angles would be congruent. So how much would they have to be? 108. It has a sum of 180. All three have to be 60 degrees each, right? So if this is supplementary, 180 minus 60 tells us that that exterior angle is 120 degrees. Now, this is going to be true with anything, but with regular polygons, we have a real special thing, because what do we know about the angles of a regular polygon? They are all congruent. So if I look, first I have a 1, 2, 3, 4, 5-sided polygon here. All of my interior angles are congruent. That's a pentagon. And we said this one interior angle of a pentagon using our formula, 180, 5 minus 2 over 5 gives us 108 degrees for the interior. So this is 108 degrees. Well, they're supplementary. So we take 180 minus 108, and that should give us 72 degrees. If each interior angle is 108 degrees, would each exterior angle be 72? Absolutely. So all of these on the exterior are congruent. So let's find out the sum of our exterior angles. We have 1, 2, 3, 4, 5 exterior angles. They're each 72 degrees. So 5 times 72 is 360 degrees. Cool. Well, what if we upgraded that to a different polygon with different sides? We've got 1, 2, 3, 4, 5, 6 sides here. So all of these are congruent, and it's 6-sided. So your n is equal to 6. 180, 6 minus 2 over 6 means each one of these is 120 degrees on the inside. So how much should that exterior angle be, guys? 180 minus 120 tells me it should be 60. So if each one of these is 60, there's 6 angles. 6 times 60 is 360 degrees. How about that? They're the same. The exterior angles have the same sum. Do y'all think that means something? I think it does. I think it really does. It's going to happen every time. Doesn't matter how many sides we do. So here's a lovely little chart. I highly suggest y'all keep this somewhere. I think it's real important. So we have 2 columns and 2 rows. So the top row is for interior angles only. The bottom row is for exterior angles. What did we just discover about exterior angles? They have a sum of 360 degrees. Now what about interior? Well, the interior has a sum of 180, and we already talked about this, n minus 2, with n being the number of sides. Now, something that's real important is this side over here talks specifically and only about regular polygons, guys. Regular polygons. This whole column is only about regular polygons. So not any wackadoodle looking triangles, no rectangles. Rectangles are not a regular polygon. No strange shaped octagons. It has to be a regular polygon. So all your sides and all your angles have to be congruent. Now for the exterior angles, you do 360 over the number of sides, and you find out one exterior angle of a polygon. And for one interior angle, since they're all congruent, we take the sum, which is written right there next to us, 180 and minus 2, and just divide that by the number of sides, or n. So let's see if we can figure out some of our last examples, and then you can knock out some homework. Okay, so what is the sum of the interior angles in a regular hexagon? So I highly suggest going through with like a highlighter, colored pencils or something, and highlighting which words it's asking you for. So it says sum, that's a pencil, not a highlighter. Sum and interior and regular hexagon. So if you're talking about regular hexagon, that's usually the right-hand side, but we're talking about sum. So we're actually going to look on the left-hand side of our table. So the sum of the interior, so sum and interior means we're using the top left equation, 180 times n minus 2. And we're doing with the hexagon. Hexagon has how many sides, guys? These you will have to remember. I'm not going to give you a chart that says a hexagon has 6 sides. So polygons between 4 and 10 sides, you need to know the names of to be on your quiz and test. I will not tell you what they are. Again, I will not tell you how many sides are in a heptagon or an octagon or a nonagon or a decagon on your quiz or test. You need to know that. So start making flashcards, Quizlet, whatever, to make sure you have all those memorized. Anything larger than 10 sides, we will explain it to you. So the sum of the interior angles, so sum, 180. The hexagon is going to tell us our n is 6, so 6 minus 2. So the sum is 180 times 4, 720 degrees. Now it tells us what's the measure of each interior angle. Well, I just take that number and divide it by the number of sides. So 720 over 6, divide by 6, and that's 120 degrees. So one leads us to the other, which is kind of nice. All right, one interior angle of a regular nonagon. Nonagon. Anybody want to guess how many sides of that? One interior angle of a nonagon, 9 sides. So we're dealing with an n of 9. And it tells us it is 7x plus 14. So first I need to find out what the actual number is. Oh no, we crashed. Let's see if we can get that back up without losing too much information. Fingers crossed, guys. Yay! Just lost my highlighting. I can deal with that. I can absolutely deal with that. Regular nonagon, one interior angle, 7x plus 14. Okay, so our n is 9. So first I want to find out how much one angle is. So I'm going to plug it into our measurement of one regular polygon interior angle, which is 180. 9 minus 2 over 9. And after I plug that into my handy dandy calculator, I get 140 degrees. So it tells me 7x plus 14 equals 140 degrees. And now I just solve for x. Subtract out that 14, then divide by 7. X is equal to 18, guys. As we start moving through these, I'm not going to show as many of these steps because some of this Algebra 1 stuff should be second nature now, solving for x when you have a simple equation such as that. So I'm not going to show you, I'm subtracting out 14. I'm not going to show you the dividing by 7. But this information is enough for me on a test or a quiz as far as showing work. So make sure you show the setup and then the final answer. All right. Next question. A